Hi guys! In this video we will be learning about the concept of a natural hazard and its potential impacts. We will also look at the relationship between risk and vulnerability and the different ways that natural hazards are managed.
Firstly, we are going to look at the concept of a natural hazard and its potential impacts. So, a natural hazard can be defined by this definition, which is that it is a perceived event that threatens life and property. Natural hazards often end up resulting in the loss of life, as well as things like property and damage to the environment, as well as disruption to other human activities. These events only become natural hazards when humans are involved, and this is because humans live in disaster zones, which makes the event hazardous. If an event such as a volcanic eruption were to happen where nobody lived, then it would not be a natural hazard, it would just be a volcanic event. So natural hazards relate to the effect to humans living in areas where natural hazards occur. So types of natural hazard that we can see in these photographs above are volcanic activity, earthquakes and tropical storms, although there are some others, but these are the main ones we are going to focus on. Natural hazards have a variety of characteristics which are mostly similar across all hazards. The first is that they have clear origins, so they are derived from a specific event such as a volcano, an earthquake, or a storm. They often have a short warning period. That means they cannot be predicted easily because they happen as freak events and there's no way that long-term prediction can take place. Also, they have different types of exposure to risk. So risk can be voluntary or involuntary. And voluntary means that people have chosen to live in a specific area that is threatened by natural hazards, but they've chosen to live there out of their choice. And this normally happens in more developed countries or more economically developed countries where there is better prediction and prevention strategies. But involuntary exposure to risk is normally in less economically developed countries where people are simply too poor to be able to decide where they want to live and therefore are forced to live in hazard zones. Also, another characteristic is that they often have long-term effects, and this can be on things such as the economy of the area, or they could be long-term environmental effects, such as a lack of crops growing because the cropland has been destroyed. And often most of the time they require an emergency response. Now we're going to move on to look at risk and vulnerability, which are two concepts that are highly related to natural hazards. And first of all, we're going to look at risk. So first of all, we'll start with a definition, and risk is the exposure of people to hazardous events. And thus they are threatening their own lives, their possessions, the environment, and others. And across the world, because people live in hazardous zones, they are constantly putting themselves at risk. And I've made a note of this over here. So there are many reasons why people put themselves at risk, and I'm going to go through them now. The first reason is that natural hazards are often unpredictable, and there's no certain way of telling when they're going to occur, and sometimes they might not happen for hundreds of years or maybe a couple of years, so people think it outweighs the benefits to live in an area because of the unpredictability, and people think that it won't happen to them. For some people, the reason is a lack of alternatives, and this is often the case in poorer countries due to poverty, and impoverished people don't have a choice of where they get to live, so they don't have any alternative but to live in a hazardous zone. And for some people, it's simply that the cost of living in this area outweighs the benefits. So some people might live in a specific area for their job or for education, and the benefits of a particular job or particular school someone goes to might outweigh the benefits of potentially living in a hazardous zone. And another reason is changing levels of risk, and this relates to things like deforestation, which is the removal of trees, and this can cause increased flooding. So people may live in an area and over time it becomes more and more deforested for maybe agricultural purposes, and this is a place that people have chosen to live and they're not willing to move, but as they live there, the risk levels of flooding are increasing. Now, on the other hand, we have vulnerability, which is linked to risk, but vulnerability means the potential for loss. So risk was the exposure of people to hazardous events, but vulnerability relates to the potential for the loss of life or possessions or the loss of a good environment. And vulnerability is different from risk because it varies over time and space, and it is more linked to economic development and wealth. So a country's vulnerability might change, for example, if it becomes more economically developed and it is wealthier, and wealth is really critical to vulnerability, and they still have the same level of risk, but they would be less vulnerable if they were to be able to afford better protection. So this is how vulnerability and risk are linked together. Vulnerability is very much focused on wealth. So having greater wealth means greater technological advances, which can be used for predicting and preventing hazardous events, such as the building of better flood walls. And it also means with wealth that countries might have better emergency services. And finally, wealth also is linked to education. And if people are more educated about where they live and the hazardous environments around them, then they're more likely to be prepared for an event, and this can result in the less loss of life and possessions and less damage overall. No matter where people live, people perceive hazards in different ways. So these perceptions can be influenced by a number of factors, including social economic status, education, occupation, religion, family, personality, and past experiences. So to say, for example, someone has lived through an earthquake and they didn't lose anything, things remained pretty undamaged, they're more likely to have a better perception of earthquakes and be more safe about where they live and be more confident in the fact that they're not going to get hurt because they survived a past experience. Whereas people who might have had a bad experience might have a worse perception of natural hazards. It is also important to note that perceptions will determine an individual's course of action. So linking back to the factors that we just looked at here, if someone is living in a rather safe part of the world where they're wealthy, they have good education and a good socio-economic status, they will be more linked to this preparation perception. So these people will be better prepared to withstand events, as they'll be more educated about what to do and so on, whilst other people who might be, for example, impoverished, which means they live in poverty, they might feel more helpless and they might think that natural hazards are just a way of life and that it's God's will almost. So they are less caring about whether they survive or not because they think that natural hazards are a way of life, and if they die, then so be it. So aside from this, there are 3 different types of perceptions that people have, and these are fatalism, adaptation, and fear. And I'm going to go through these types in more detail. The first type of perception is fatalism, and this means acceptance. This means that, as linked back to the helplessness that we just talked about, is that natural hazards and natural events are part of living in an area and they are God's will, so any losses are inevitable. The second type of perception we have is adaptation, and these are the people that we just spoke about who are willing to prepare for an event, and therefore they have the will to survive an event. So they will survive these events through prediction, prevention, and protection, which are 3 actions we're going to look at in more detail later on. But these people who have this adaptation perspective are pretty much dependent on the economic and technical circumstances of the area that they're living in. So adaptation is limited by economics and technology. So obviously this will be better in a more economically developed region rather than a less economically developed region. And our last type of perception is fear. And this is that people feel so vulnerable that they will simply move away from the area or from where the hazard is located. Moving on, we're now looking at the management of natural hazards. And people respond to natural hazards and their threats by seeking to reduce the risk of natural hazards. And this can happen on a range of scales, from individual to government. So individual might be choosing where you live or living on higher ground if you are subject to flooding, for example. And also governments reduce risks by implementing emergency plans or strategies. One way of reducing risk is to kind of facilitate community resilience, which means that a community can utilize available resources to respond to the hazard. They are able to withstand and recover from the events of the natural hazards, and this tends to minimize the effects of a hazard and makes it easier to return to normal life. So it minimizes the effects of the hazard. And this is something that communities really want to strive for. So just to repeat, they want to utilize the materials they have to be able to withstand and recover from the event. And by this, they are reducing the risk of any major damage or loss to life. On a larger scale, most governments use an integrated risk management scheme, which involves identifying the hazard initially, so identifying whether you live near a volcano or a tectonically active area where earthquakes might occur, and then they analyse the extent of the risk. They will then work out their priorities to do with the risk, so they might look at people who are more susceptible to loss, such as poorer people, and then they will plan their strategy. Then after planning their strategy, they will look into public awareness to make sure that the people know about the risk of living in the area, and they will work on a communication strategy, so when a hazard does occur, they'll be able to communicate effectively and provide effective warnings. And this will enable people to leave the area in time. And following this, up till a said event, they will monitor the area, and this will help provide a faster response if something were to happen. But on the whole, the method that most people and governments use to reduce risk and manage risk is through prediction, prevention, and protection, which we can remember as our 3 Ps. So prediction involves using things like satellites and other kind of monetary processes to provide warnings. For example, we have sensors throughout the seas which will be able to detect when an earthquake might occur and then can provide warnings about tsunamis. And these are hazards we're going to learn about more in later detail. But yes, prediction is the first part. Then we have prevention, and preventing natural hazards is completely unrealistic because there is no way we can try to stop them. But sometimes the extent of a natural hazard can be slightly prevented, such as sometimes when storms are occurring, they might try to what's called seed clouds, which means to create more clouds in said area where the storm might be forming, and this would intend to weaken the storm by making it rain more overseas before the storm reaches land. So that can be a way of prevention, but for prevention is normally unrealistic. There is no way to stop a volcano exploding, for example. And lastly, we have protection, and this aims to protect people and their possessions and the environment and this could be through making buildings earthquake proof, or for example building flood defences. Now we're going to look at some models which are used to demonstrate the disaster response curve, and this was developed by someone called Park, so it's known as Park's disaster response curve. And these curves demonstrate how natural hazards have varying effects over time. So the typical disaster response curve shows the initial point where the hazardous event takes place. So along here we have time, and this axis here is kind of the quality of life, so I'll abbreviate that as QOL. So here, before the event, as you can see it says pre-disaster here, we have a normal level of quality of life. As the event takes place, the quality of life will dramatically decrease as the event is taking place. Then we reach a kind of the bottom of the curve, and this is when emergency relief is taking place. So this is when the emergency services deal with it. And then you see we have quite a long way back till we reach normality again. And this is when we have our rehabilitation stage, which I've marked out here. So I'm just going to write here, relief is the initial emergency response. Then we have our rehabilitation stage afterwards, which is when things like food and shelter are provided to the area and the quality of life will improve a little bit. And then we have our reconstruction phase, which is when infrastructure starts to be rebuilt, and only after a very long time, this could be from weeks to years, that quality of life returns to its normal levels. And sometimes they may not actually return to their normal level and might kind of curve off here and stay below the level of normality due to the event. And finally, I've just got this graph down here to show you that the graph is not going to be the same for all hazardous events. So for some hazardous events, when the event takes place, there'll be more significant impacts, so quality of life will reduce a lot more, and there'll be a slower path back to normality, whilst there might be other kind of less damaging events, such as this blue area here. If you follow this line, and they will return to normality much faster. So yes, not all disaster management curves will show the same shape. Very quickly, we're going to look at distribution, frequency and magnitude, and all you really need to know about these is what their definitions are. So starting with distribution, this is the spatial coverage of a hazardous event. So this can be local or global. For example, a storm is most likely to have a more local event, whilst a global event could be an underwater earthquake causing a tsunami, which is a huge wave which travels across the oceans and causes major flooding to areas. So I've shown you in this photo here. It's not that visible, but in this red dot we have here, that was the epicenter of the earthquake, which is where the earthquake first started. And we're going to learn more about earthquakes in more detail in other videos, but the earthquake started here, but the tsunami waves, which were very large waves, ended up hitting the coast of India, shown in red, all these islands around Indonesia, and these waves also caused destruction all the way across to Africa at the coast of Somalia, as shown here. So this shows you how some hazardous events will have a global spatial coverage. And then we have frequency, and this is the distribution of hazards through time. And this essentially means that, or this indicates the frequency of an event, so how many times it will potentially occur in a specific area. So I've got this map here to demonstrate the Ring of Fire. Now, the Ring of Fire is an area of plate boundaries where volcanic events and earthquakes take place very frequently, because these are destructive and constructive and conservative plate boundaries where lots of tectonic activity takes place, whereas you've got places in the middle of plates, such as the Eurasian plates, where we don't find we have many earthquakes or volcanoes at all. So we'd say that the frequency was higher around the Ring of Fire and less frequent in the middle of tectonic plates. And finally, we have magnitude, which is the size of an impact. So to give you an example, earthquakes are measured on the Richter scale. So the Richter scale shows the magnitude of an earthquake, starting at 0 being a non-event, so it was barely felt, and 10 being a permanent event that caused massive destruction and changed the future of civilization, as shown here. So yes, the magnitude of earthquakes increases from 0 to 10 on the Richter scale. And lastly, I'm going to give you a brief introduction to the effects of natural hazards. So the effects can be human or environmental. So human effects would be the loss of life or damage to property, whilst environmental hazards might be damage to crops or infrastructure, which is roads and electricity. And these effects can be classified as either primary or secondary. So primary simply means the effects that happen at first instance, and secondary hazards occur later on. So to give you some examples, a primary effect could be death, which is pretty instantaneous, and this can happen when something's hit by a falling building or so on. But a secondary effect could be disease, and disease wouldn't happen right as the event is happening, but say an area was flooded and lots of people got very sick after the flooding event, so this would be a secondary effect.
Hi guys, I hope you enjoyed the video. If you're looking for an amazing A-level geography resource, join me today in my series of engaging bite-sized video tutorials. See you soon, and together let's make A-level geography a walk in the park.